Imagine investing in two assets. One goes up, the other goes down. Sound risky, right? Wrong. That might actually reduce your risk. In this video, I will show you the real secret behind diversification using covariance, correlation, and portfolio risk. If you understand expected return in part 1, this is where things get powerful and the exam questions start getting tricky. From part 1, we learned expected return of portfolio. We said expected return of portfolio or portfolio returns equal to what? Plus WB RB, where WA and WB are weights, and RA bar and RB bar are expected returns. Expected returns. But here is the problem. Expected return does not measure risk. And in real life, investors care about risk just as much as return. So today we move into covariance, correlation, standard deviation. These three determines whether diversification actually works. What is risk? Risk in finance means uncertainty of returns. It means uncertainty of returns. We measure it using variance and standard deviation. We measure risk using variance and standard deviation. So what is variance? What is variance? Variance measures how far returns are from their average value. How far returns are from their average value. It measures how spread out are the returns. It measures how returns spread out. Variance can be categorized into two. We have small variance and large variance. Small variance means returns are close to average. The risk for this is very low. Large variance means returns are far apart. Large variance means returns are far apart. The risk for this is high. The risk for large variance is very high. So we want to examine the formula for calculating variance. So high title, I'll be using this symbol for variance. So I'll be using this for variance. So the variance is square. So it's a square of the deviation. Variance. Variance. So variance equals to sum of probability into R minus R bar, all in square. Remember, P is probability. Probability. R is returns of the portfolio or portfolio returns. R bar, that is expected returns. Expected returns, which is the mean. Expected returns. And to calculate your expected returns, R bar, that is probability, sum of probability times returns. Probability times returns will give us the expected returns. Sum of probability times returns will give us the expected returns. So, and This is variance. Variance. So that is the formula for calculating the variance. Having know the formula for calculating the variance, we therefore want to examine the standard deviation. Remember, variance measures spread. It measures spread. Variance measures spread. What is standard deviation? Standard deviation. Standard deviation is the square root of variance. That means before you can calculate the standard deviation, you must have known the variance. So after you have calculated the variance, just find the square root of variance. It will give you the standard deviation. Standard deviation equals to standard deviation equal to square root of variance. And remember, our variance is this. That means standard deviation equals to square root of sum of P into returns minus expected returns square. So that is the formula for calculating the standard deviation. Example 1. This question is obtained from ICAN study test, financial management. From the table below, compute the expected return, variance and standard deviation. We have state, we have probability, we have expected returns. Expansion, probability of 0.25, expected returns of 5%. Normal, probability of 0.50, expected returns of 15%. We have for recession, probability of 0.25, and we have the expected returns of 25%. Solution. You have to compute the expected returns. I've told you that expected returns, which is the mean, expected returns. The formula for calculating the expected returns equals to probability times the returns. Sum of probability times the returns. So, and you have the probability of 0.25, then 0.50, and 0.25. Then the returns given. Returns are 5%, 15%, and 25%. So, based on the formula, we have probability times the returns. And the probability we are given. So, now let's create a column for probability times returns. Probability times returns. In order to get the expected returns, 0.25 times 5. Then we have 1.225. Then we have 0.50 times 15. That gives us 7.5%. Then 0.25 times 25. That gives us 6.25. So if you sum it up, the expected returns is, that is R bar. You know the expected return is R bar equals to this. So what is the R bar now? The expected returns, that is the sum of this. 6.25 plus 7.5 plus 1.25. We have the expected returns of 15%. So that is the expected returns. So our expected return equal to 15%. So now that we've gotten the expected returns, you are equally asked to calculate the variance. And the formula I gave you for variance equals to sum of P into R minus R bar squared. This is the formula for calculating the variance where probability is given. So the R is this. R bar, which is the expected return as calculated. R minus R bar, that is the derivation. But this contains square, so we have a column for that. R minus R bar square. Then here again, we have probability multiplied by that. Let's have probability multiplied by R minus R bar square. Then we've gotten all the variables. So the next is just to sum up this. And this is this column. So we sum up the results obtained at that column. Remember R bar. R bar, that is the expected returns, is 15% as calculated. So it means anywhere you need R bar, you use 15% in place of R bar. 5, which is R, minus R bar, which is 15. 5 minus 15, that gives us minus 10. Then R minus R bar squared, that is the square of what you have here. If you square this, it will be plus 100. That is minus 10 squared is plus 100. That is minus 10 times minus 10. Minus times minus become plus. 10 times 10, 100. So which is plus 100. Then we need to multiply this by the probability. And the probability at this column is 25%. 25% of 100, that gives us 25. Then for this second column, R is 15. R bar, which is the expected returns, and that is equally given to be 15, or has equally been calculated to be 15. So we have 15 minus 15, that will be 0. And the square of 0 is 0. Probability of 0.5 times 0, that will also be 0. Please take note of that. Then the third column, which the R is 25. R bar 15. 25 minus 15. That will be 25 minus 15. That is plus 10. 10. If you square 10, 10 square, that is 10 square, which is 10 times 10. That gives us 100. Then 0.25 times 100, that gives us 25. So if you sum up this, it gives us 25 plus 0, 25 plus 25, that is 50. Then the sum of it now. Remember, the sum of all these is the variance. That means we have the variance. You know, the formula for variance, we have variance equal to summation of P into R minus R bar square. And the sum of P into R minus R bar square, that is 50. That means the results obtained, that is a variance equal to 50. Variance equals to 50. Now, we've gotten the variance. Then the final answer, the last thing required is the standard deviation. And remember, I've told you that standard deviation is the square root of variance. It's standard deviation. So for the standard deviation, it will not carry square. Equal to square root of variance. And our variance is summation of P into R minus R bar square. So which is the same formula we use here. Only that when you find the square root disappear, then this square root will come on this. So we have this, we have square root of everything here is 50. So if you find the square root of 50, that will give us the required standard deviation. Square root of 50, that is 7.07. Therefore, we have the standard deviation to be 7.07, which is the square root of 50. Therefore, standard deviation equals to 7.07. That is the solution to example 1. Covariance is one of the variables we need the measuring portfolio risk. Covariance. What is covariance? Covariance measures how two investments move together. It measures how two investments move together. In simple terms, covariance answers this question. When one investment goes up, what happens to the other? When one investment goes up, what happens to the other investment? There are three possible outcomes. 1. Positive covariance. Positive covariance. Negative covariance. Three. Zero covariance. Positive covariance means both investments moves in the same direction. Investment A and investment B moves in the same direction. That is, if stock A increases, stock B also increases. If stock A decreases, stock B also decreases. Example, two banks in the same economy. When the economy improves, both banks' stock may rise. When the economy improves, both banks' stock may rise. That is positive covariance. Number 2, we have negative covariance. Negative covariance means the investment moves in opposite directions. The investments move in opposite directions. That is, if stock A goes up, stock B goes down. If stock A goes down, stock B goes up. This is good for diversification because one investment can offset the losses of another. Number 3, we have zero covariance. Zero covariance. Zero covariance means investment do not have any relationship. There are no relationship at all between the investments. The movement of one investment does not affect the other. Covariance between A and B equals covariance between A and B equal to summation of probability into returns of A minus expected returns of A multiplied by returns of B minus expected returns of security B. So that is bar RA mean expected returns of security A, which is the mean. P stands for probability. P equal to probability. RA, that is returns of asset A or security A. RA bar, that is expected return of asset A. RB, that is return of asset B or security B. RB bar, that is the expected return of asset B. So when we say expected return is the mean equal to arithmetic mean. And to calculate the expected return return equals to probability times the return. So when you multiply the probability by the return, that will give you the expected return. Covariance is good, but it is difficult to interpret. Hence, the need for correlation coefficient. In other words, covariance is useful, but it has problem. It is hard to interpret. Hence, there is need for correlation coefficient. Correlation tells us how strongly assets move together. It tells us how strongly assets move together. Correlation coefficient take a range of numbers between -1 to +1. It take a range of number between -1 to +1. If you have +1 means perfect positive correlation. You have -1, that is perfect negative correlation. And you may equally have zero correlation. Zero correlation. If you have zero, if the result is zero, so that means you have zero correlation, no relationship. There are a number of cases which you must know. Cases you must know. We have case 1. Case 1, which is perfect positive correlation. This is where correlation coefficient is +1. Correlation coefficient equal to +1. So that is perfect positive correlation. This occurs where assets move exactly the same way. It occurs where assets move exactly the same way. No diversification benefit in this case. There is no diversification benefit. Case 2. Case 2. That is perfect negative correlation, where correlation coefficient equals to -1. That is perfect negative correlation. This is gold. This case is a gold. You can eliminate risk completely. Where your correlation coefficient is negative, so you can eliminate risk completely. So it is the best option. Then we have case 3. Case 3. Zero correlation. Partial diversification benefit. Relationship between covariance, correlation coefficient, and standard deviations. Covariance between two security X and Y. Covariance XY equals to correlation coefficient, between the two security X and Y times standard deviation of X, standard deviation of security X, times standard deviation of security y. Standard deviation of y. Therefore, covariance xy, that is of the two security x and y, equal to correlation coefficient s of security x and y times standard deviation of security x times standard deviation of security y. So, if you make your correlation coefficient the subject of the formula, so that means you need to divide both sides by this. If you divide both sides by standard deviation of security x and standard deviation of security y, then you'll be left with correlation coefficient between the two security. So that means correlation coefficient between security x and y will be equal to covariance of the two security x and y over standard deviation of security x times standard deviation of security y. So this is the formula for calculating the correlation coefficient. And remember covariance formula, which I've given earlier. So under covariance, I've told you that covariance between the two security x and y will be equal to sum of probability multiplied by returns of security x minus expected returns of security x into returns of security y minus expected returns of security y. This is the formula for calculating the covariance. So we want to examine the steps for calculating correlation coefficient with probability. Steps for calculating the correlation coefficient. Where there is probability. Probability. So step number 1. The first step is to calculate the expected return. Calculate the expected return. That is the first step. Calculate the expected returns. Remember, I've told you that expected returns of security, expected returns equal to probability multiplied by the return of the security. That means to calculate the expected return of security S, we have expected return of security S into probability times returns of security X. So the first step is to calculate the expected returns. Step 2, calculate the standard deviation. Calculate the standard deviation. Remember, I've told you that standard deviation is the square root of variance. Is standard deviation equal to the square root of variance? That means standard deviation will be square root of summation of P into returns minus expected returns square. So that was the formula I gave you for calculating the standard deviation. The step 3 is to calculate covariance. Calculate covariance. I've told you that covariance of security, let's say x and y, that will be equal to summation of probability times returns of security x minus expected returns of security x into returns of security y minus expected returns of security y. So this is the formula for calculating the covariance. Step 4, substitute into the correlation formula. The fourth step is to substitute into correlation formula. Remember the formula for correlation. Step 4, substitute into the correlation formula. And what is the correlation formula? So I've told you that the correlation between the two security X and Y, I said, is equal to covariance of security X and Y over standard deviation of security X multiplied by the standard deviation of security Y. So, and the formula for covariance is this. That means the correlation coefficient between the two security will be equal to covariance of security X and Y, which is sum of probability into returns of security X minus expected returns of security X into returns of security Y minus expected returns of security Y. So that is the covariance over the standard deviation of security X multiplied by the standard deviation of security Y. Example 2. This question is obtained from Workout Strategic Financial Management by Adeomoleiwa. You have the following data about stock A and B. Stocks A and stock B. We have current price 60 and 80 for stock A and B respectively. Expected return in 1 year with probability. Probability of 30%. We have the returns of 66 and 92. Probability of 50%, we have returns of 72 and 104. And at the probability of 20%, we have returns of 51 and 62. All prices are in Naira. A. Calculate the expected return and volatility, that is standard deviation, for each stock over the 1 year period. B. Calculate the correlation coefficient between the two stocks. Solution. Since the returns are not given in percentage, you will need to calculate the return in each scenario. You need to calculate it in percentage. Step 1. Calculate the returns in percentage. You have 3 classes of returns. Returns 1, return 2, return 3. 3 returns. So, and to calculate the returns in percentage, the formula is return equals to P1 minus P0 over P0 times 100. Or you make use of this formula. Returns equal to P1 over P0 minus 1 times 100 over 1. So you make use of either of the two formula, where PO is the current price, where PO equal to current price, P1 equal to future price. P1 equal to future price. So, applying this formula, I will use the two formula for comparison purpose. So, now for for return 1, our P1 is 66. That is the future price, 66, minus PO PO is 60, which is current price. 60 over PO, which is 60, times 100 over 1. This is for stock A. Stock A. 66 minus 60, that would be 6. 6 over 60 times 100, that gives us 10%. Return 2. We have 72 minus 60. 72 minus 60 over 60 times 100. That gives us 72 minus 60, that is 12, divided by 60 times 100. That gives us 20%. Return 3. I mean the scenario 3. The return is 51 minus 50. 51 minus 50 over 60 times 100 over 1. That gives us 51 minus 60. That is minus 9 divided by 60 times 100. That gives us minus 15%. Minus 15%. These are the expected return for each of the 3 scenarios for stock A. And if you want to make use of the second formula, the second formula is P1 returns, which is P1 over PO minus 1 times 100 over 1. The P1, return 1, the P1 is 66. 66 over PO, which is 60, minus 1 times 100. 66 divided by 60, that gives us 1.1. 1.1 minus 1, that gives us 0.1 times 100. That gives us 10%. If you do the same thing for scenario 2 and 3, you will get 20% and minus 15% respectively. So you can apply either this formula or this second formula. So expected return. Expected returns. Expected returns equal to probability times the returns. So, and we have 3 scenarios. The probability of scenario 1 is 30%, which is 30% times the returns, or let me modify the formula. Expected returns will be probability 1 times returns 1, since it's probability times returns, plus probability 2 times returns 2, plus probability 3 times returns 3. So expected return, the probability 1 is 30%, which is 0.3. If you say 30 divided by 100, it gives you 0.3, times the returns 1, which is 10%, plus probability 2, which is 50%, 0.5. 50 divided by 100 gives us 0.5, times return 2, which is 20%, plus probability 3, which is 20%, which is 0.2, times return 3, which is minus 15%. Minus 15%. So 0.3 times 10, that gives us 3%, plus 0.5 times 20, that gives us 10%, plus 0.2 times minus 15, it will be minus 0.2 times minus 15, that gives us minus 3%. Therefore, expected returns of stock A, so is For stock A, 3% plus 10, that is 13% minus 3%. So you have 10%. That is the expected return of stock A. You have to calculate the expected return and volatility, that is standard deviation for each stock over the 1 year period. Now you've gotten the expected return, then you need the volatility, that is the standard deviation of stock A. So we want to compute the standard deviation of stock A. And I've told you that standard deviation is the square root of variance. So standard deviation equal to square root of variance. And variance is sum of probability into returns minus expected returns, all square. So this is the formula for finding or calculating the standard deviation. If I use small letter r in the earlier formula, it's still the same. I may use small letter r or capital letter R, so they are the same. Now we have the returns. Stock A now. Stock A. Returns. The returns, which is R. The return from stock A is 10%, 10%, 15%, 10%, 20%, and minus 15%. 10%, 20%, and minus 15%. And those were the returns used here, 10%, 20%, minus 15%. And you are given the probability of stock A, 30%. The probability you are given 30%, 50%, and 20%. Those are the probability you are given. So we have probability of 30%, which is 0.3, 50%, which is 0.5, and we also have 0.2, which is 20%. Now, the expected returns, though we've calculated that here above, or you may equally show it in the table like this, which is probability times returns. So this gives us 3%. Everything is in percentage. 3%, 10%, and the minus 3. This are the expected return, and the total of this is 10, which was the expected return as calculated. If you don't want to show the calculation like this, so you may show it in form of table like this. Now that you know the expected returns, by virtue of the formula, we know our target is the standard deviation. The R bar is the expected returns. So you want to calculate the standard deviation, that means you will need R minus R bar. R minus R bar. Then you will equally need R minus R bar square. R minus square. Then it is not just like that. You will need to multiply by the probability. So we have probability into R minus R bar square. The R bar is the expected returns. And our expected returns, that is R bar, is 10% as calculated. 10% or this. So R is 10% here. R bar is also, R bar from our calculation is 10%. That means we have 10 minus 10. That will be 0. 20 minus 10. That will be 10. Minus 15 minus 10. That will be minus 25. Minus 15 minus 10. Minus 25. Then you need the square of it. The square of this is, square of 0 is 0. Square of 10 is 100. Square of 25 will be 625. 625. Then you multiply by the probability. 0.3 times 0, it will still be 0. Then 0.5 times 100, that will be 50. 625 times 0.2. That gives us 125. If you sum this up, you have the variance to be 175. 0 plus 50, 50, 50 plus 125, that will be 175. Now that you've gotten the variance to be 175, we said the standard deviation equal to square root of variance, and which is sum of P into R minus R bar square, which is square root of sum of P into R minus R bar square, that is 175 as calculated. Therefore, the standard deviation will be equal to, what is the square root of 175? 13.23. So we have the standard deviation to be 13.23%. So that is the standard deviation of stock A. Remember, the question asks for the volatility, calculate the volatility, that is standard deviation, for each stock over the 1 year period. For each stock. We've done with that of stock A. Then you want to do that of stock B. So you also start from where we started that of stock A by calculating the returns, the expected returns of stock B. Stock B. So we want to calculate the returns. Calculate return in percentage. Return of stock B. So using the same formula, so we have returns 1, which is the price is 92. That is future price 92 minus current price 92. Or let me use the second formula. So I want to use the formula returns equals to P1 over PO minus 1 times 100 over 1. So you may use this second formula. So if you use the first formula, you will still get the same thing. So return A. So return 1. The first return 92 over 80. The current price is 80 minus 1 times 100. That gives us 92 divided by 80. That is 1.15 minus 1 times 100. So we get 15%. The first return is 15%. Return 2, which is 104 over 80 minus 1 times 100 over 1. 104 divided by 80 minus 1 times 100. That gives us 30%. 30%. Then return 3, which is 62 over 80 minus 1 times 100 over 1. That gives us 62 divided by 80 minus 1 times 100. That gives us minus 22.5%. Minus 22.5%. So these are the returns. They want to calculate the expected return and volatility for stock B now. So stock B, continue. So we have returns. The first return as calculated is 15%. The second one is 30%. And the third one is minus 22.5%. The probability 0.3, which is 30%, 0.5, which is 50%, and 0.2, which is 20%. So what is the expected return? Expected return is probability times returns. So 15 times 0.3. That is 4.5%. That is probability times returns, which is 4.5. 30 times 0.5. So this is 4.5%. This gives us 15%. Minus 22.5 times 0.2. That gives us minus 4.5%. So the expected return, if you sum up these, it gives us 15%. So for stock B now, we have the expected return of stock B we have that to be 15%. Then the next thing to calculate from there is the volatility, that is the standard deviation of stock B. And remember, I've told you the standard deviation is the square root of variance. And the square root of variance, which is P, sum of P into R minus R bar square. So you know your R to be this. And our R bar, which is the expected return, which is 15% as calculated. So we need R minus R bar. Then we need the square of it. R minus R bar square. Then we need to multiply by the probability. Probability into R minus R bar square. Our R is this column, and our R bar is 15% as calculated. 15% minus 15%, that will be 0. The square of 0 will be 0. Then probability times the square of this, which is 0.3 times 0, that will still be 0. Then for this, 30 minus 15, that will be 15. The square of 15 will be 225. The square of 15 is 225. 225 times probability of 0.3, 0.5 rather, times 0.5, which is the probability. That is 112.5. 112.5. Then for this column, the returns is minus 22.5 minus the expected returns of 15. Then you have minus 37.5. Minus 37.5, all calculations are in percentage. Minus 37.5, if you square that, that is 1406.25. If you multiply it by the probability of 0.2, that gives us 281.25. 281.25. So if you add 281.25 and 112.5, so the total is 393.75. 393.75%. So, and this is the formula for calculating the standard deviation. So, which is the square root of variance. And our variance is 393.75. What is the square root of that? We have 19.84%. Therefore, the standard deviation of stock B is 19.84%. So we've done with the solution to A, which requires us to calculate the expected return and the standard deviation for each stock. The B is requesting for the correlation coefficient between the two stocks. Correlation coefficient between stock A and B. I've told you that the correlation coefficient is covariance of the two stocks, that is stock A and B, over standard deviation of stock A, standard deviation of stock A, and standard deviation of stock B. And the covariance, the formula for covariance is summation of P into return of stock A minus expected returns of stock A into returns of stock B minus expected returns of stock B. To calculate the correlation coefficient between the two stocks, you will need the covariance between the two stocks. We know the standard deviation of stock A. We equally know the standard deviation of stock B. So what we are in need of is the covariance between the two stocks. And the formula for covariance is this. And remember, so you have probability. The probability, the first probability you are given is 30%, which is 0.3. Probability is 0.3, 0.5, and 0.2. These are the probability given in the question. You need, after the probability, you will need returns, RA minus returns of A. RA, returns of A minus expected returns of stock A. And these have been calculated from the table where we calculated the standard deviation of stock A. So, this is for stock A. So, we have the R returns minus expected returns. R minus expected returns, that is R minus R bar, which is 0, 10, and minus 25. That is the value of R minus R bar. So remember, I modified the formula by including A so that you know that the calculation is for A. So we have R minus R bar, which is 0, 10, and minus 25. Then we equally need that of stock B. R returns of B minus expected returns of stock B. For stock B, and that have equally been calculated, and we got that of stock B to be R minus R bar is 0.15 minus 37.5. Is 0.15 minus 37.5. So by virtue of the formula for covariance, you are in need of probability multiplied by returns of stock A minus expected returns of stock A, then into returns of stock B minus expected returns of stock B. So that means you need probability times returns of A, probability times deviation in A times deviation in B to get the whole of this. So you'll be multiplying the three columns. Is 0.3 times 0 times 0, that would be 0. Is 0.5 times 10 times 15, that gives us 75. Then 0.2 times minus 25 times minus 37.5. This gives us 187.5. If you sum up the three results, is 0 plus 75 plus 187.5, 75. Then you have 262.5. That is the covariance of the two stocks. And remember the formula for correlation coefficient between the two stocks. We said the correlation coefficient between the two stocks equal to covariance of the two stocks over standard deviation of the stock A multiplied by standard deviation of stock B. And the covariance is 262.5 as calculated over what is the standard deviation of stock A. The standard deviation of stock A as calculated is 13.23. 13.23 13.23 multiplied by the standard deviation of B, which is 19.84 from our calculation, 19.84. Now that you've gotten the standard deviation and you've gotten all the variables required to calculate the covariance, correlation coefficient rather, equal to 262.5, which is our covariance, over what is the product of the denominator? 13.23 times 19.84. That gives us 262.4832. So if you divide it, therefore, we have the correlation coefficient between the two stocks A and B. We have 262.5 divided by 262.4832. Then we have 1. We have 1, which is positive. So plus 1. So we have the correlation coefficient to be plus 1 from the result. So remember, this denominator is the product of these two standard deviations. You know, the standard deviation of stock A is this, that of stock B is this. So when you multiply, that is how we got this. Portfolio risk, which is measured with standard deviation. Portfolio risk is the most important part of this lecture. To measure the portfolio risk, I've told you it can be measured with the standard deviation. Standard deviation of portfolio equal to square root of variance, and the variance equal to weight of the square of weight of security A multiplied by the standard deviation of multiplied by variance of security A plus weight of security B square multiplied by variance of security B. Variance of security B. So if you have X and Y in the question, so you may change this to X and Y. Plus 2 multiplied by weight of security A, weight of security B, standard deviation of security A, standard deviation of security B, multiplied by the correlation coefficient of the two security. Correlation coefficient of the two security, where WA and WB are weight. So this symbol is standard deviation. YR is correlation coefficient. What this means is that portfolio risk is not just weighted average of risk, it depends on correlation. Low correlation means lower risk. Negative correlation, which is major risk reduction. Example 3. An investor is considering investing in two assets. asset X and asset Y. Expected return of asset X 12%. Expected return of asset Y 16%. Standard deviation of X 10%. Standard deviation of Y 18%. The investor decides to invest 40% of their funds in asset X and 60% in asset Y. Required: 1. Calculate the expected return of the portfolio. 2. Calculate the portfolio standard deviation under 3 different correlation coefficient scenarios. Scenario A, perfect positive correlation, that is R equal to +1. Scenario B, zero correlation, R equal to 0. Scenario C, negative correlation, R equal to -0.4. Solution: the requirement 1, you have to calculate the expected return of portfolio. Expected returns of portfolio, and that is weight of asset X and return of asset X plus weight of asset Y multiplied by returns of asset Y. So you were told expected return of X is 12%. That is the return of X. RS is 12%. Expected return of Y is 16%. Return of Y is 16%. You don't need the standard deviation when computing the portfolio returns. The investor decides to invest 40% of their funds in asset X. The weight of X is 40%, and the weight of security Y, and that is 60%. So you want to calculate the returns of portfolio, expected returns of portfolio returns, weight of X, weight of X is 40%, 40% of the returns of X. Let me just use 0.4. 0.4 times returns of X, which is 12%, plus weight of Y, which is 60%, 0.6, multiplied by the expected returns of Y, which is 16%. So 0.4 times 12, that gives us 4.8% plus 0.6 times 16, that gives us 9.6%. If you sum up the two returns, then you have 14.4%. Therefore, the expected returns of portfolio is 14.4%. That is the solution to number 1. Number 2, you have to calculate the portfolio standard deviation under the 3 different correlation coefficients. So the standard deviation, the formula for standard deviation is the square root of variance. The square root of weight of security S square multiplied by the standard deviation of X, variance of S, plus weight of Y, standard deviation of security Y, or variance of Y, plus 2 times weight of X, weight of Y, standard deviation of X, standard deviation of Y, multiplied by correlation coefficient between the two securities. correlation coefficient SY. R is the correlation coefficient of the two security XY. So this is the formula for calculating the standard deviation of portfolio. For scenario A, where the correlation coefficient equal to +1. So we substitute into the formula the standard deviation of portfolio equal to root of the variance. The weight is of security S is 40%, which is 0.4. 0.4 square times standard deviation of X. The standard deviation of X is 10%. So we have 10%, 10 square, plus weight of Y is 0.4, 0.6, multiplied by square, multiplied by the standard deviation of Y. Standard deviation of Y 18%, which is 18 square, plus 2 times weight of X, which is 40%, times weight of Y, which is 60%, times standard deviation of X, 10, times standard deviation of Y, 18, times correlation coefficient, which is 1, where correlation coefficient equal to 1. So 0.4 square, that gives you 0.16 times 10 square, which is 100, times 100. That gives us 16. We have square root of the whole of this one is 16 plus 0.6 square, 0.36 times 18 square. That is 324. So the product of the two is 116.64 plus 2 times 0.4 times 0.6 times 10 times 18 times 1. That gives us 86.4. 86.4. So what is the sum of the three results? Plus 116.64 plus 16. The sum is 219.04. 219.04. So what is the square root of that? Which is 14.8%. So the standard deviation of the portfolio is 14.8%. That is the solution to the first scenario. So we want to consider the scenario 2. Scenario 2, where correlation coefficient equal to is 0. That is for zero correlation. That is what we have in scenario 2, 0 correlation. So substituting into the formula still remains the same. So we have standard deviation of portfolio equals to square root of variance, which is W square, weight of S square, which is 0.4 square, times the standard deviation of X, which is 10 square, plus weight of Y, which is 0.6 square, times standard deviation of Y, which is 18 square, plus 2 times probability 0.4 times 0.6 times standard deviation, which is 10, times 18, times correlation coefficient between the two security, which is now 0, that is 0 correlation. So, which is now square root of the whole of this gives us 16, plus this one gives us 116.64. So if you multiply 2 times 0.4 times 0.6 times 10 times 18 times 0, it will be 0. So the standard deviation of portfolio. So we have 16 plus 116.64 plus 0. That is square root of 132.64. What is the square root of that? We have 11.52%. 52%. Scenario C now. C. So the correlation coefficient is minus 0.4. That is what we have in scenario C. So the formula still remains the same. Square root of variance, and our variance as before, we have 0.4 square times standard deviation, square of standard deviation, which is 10 square, plus 0.6 square multiplied by the square of the standard deviation, which is 18 square, plus 2 times 0.4 times 0.6 times standard deviation, which is 10, times the second standard deviation, which is 18, times correlation coefficient between the two securities, which is minus 0.4. So what will be the, let's simplify this. So this will be square root of, this one is 16 plus 116.64. So the third one, we have 2 times 0.4, 2 times 0.4 times 0.6 times 10 times 18 times minus 0.4. This is 30. We have minus 34.56. So what is the sum? Plus 116.64 plus 16. Then you have square root of 98.08. Therefore, the standard deviation of the portfolio, the square root of that, which is 9.9%. So the risk involved in this is the least. So this is the best combination for the entity. Let's wrap up. Covariance measures direction of movement. Correlation measures strengths of relationship. Standard deviation measures risk. Diversification reduces risk, not by chance, but by mathematics. If this helped you understand portfolio theory better, don't forget to like, subscribe, and watch part 3, where we will go into efficient frontier and optimal portfolio. Thanks for watching.